Hi friends, welcome to my channel Magic Sir of Mathematics with Magic Methods. You will never find false claims for cheap popularity in my videos. I will help you to improve your knowledge of trigonometry. Here you will learn pure mathematics without any drama. In my previous videos, I have solved some examples with the help of trigonometric identities. In this video, we will solve the following examples one by one. I have given screenshots of the solved examples in the at a glance section. Now enjoy the video till the end. Let us take the first example. Here, left hand side is more complicated. So let us try and see what we could do with it. You have studied the method of adding fractions with unlike denominators in earlier classes. Here, the LHS is of the form P upon Q plus R upon S is equal to PS plus QR plus QS. Therefore, LHS is equal to tan theta into tan theta equal to tan square theta plus 1 plus sec theta into 1 plus sec theta equal to 1 plus sec theta whole square divided by 1 plus sec theta into tan theta. Now apply the formula of a plus b whole square equal to a square plus twice ab plus b square. Let us suppose a equal to 1, b equal to sec theta. Then LHS is equal to tan square theta plus a square equal to 1 square equal to 1 plus twice AB, that is 2 into 1 into sec theta equal to twice sec theta plus b square equal to sec square theta. We know that tan square theta is equal to sec square theta minus 1. So we can replace tan square theta with sec square theta minus 1. Here other terms remains as it is. Note that negative 1 and positive 1 cancels out. So LHS is equal to 2 sec theta plus sec square theta plus sec square theta equal to twice sec square theta divided by 1 plus sec theta into tan theta. Here 2 sec theta is the common factor. So LHS is equal to twice sec theta into bracket 1 plus sec theta divided by 1 plus sec theta into tan theta. Here 1 plus sec theta cancels out, leaving us with LHS equal to twice sec theta upon tan theta. But we know that sec theta is equal to 1 upon cos theta and tan theta is equal to sin theta upon cos theta. Here cos theta cancels out. Therefore, LHS is equal to 2 into 1 upon sin theta. Again, we know that 1 upon sin theta equal to cosec theta. CSC theta means cosec theta. Therefore, LHS is equal to twice cosec theta. Hence, we have verified the given identity. Friends, look at the second example. Which side is more complicated in this equation? Here, the left hand side is more complicated. So we will take the left hand side for simplification. We can observe that twice sin theta is a common factor in the numerator. So taking twice sin theta as the common factor from the numerator, we get the left hand side is equal to twice sin theta into bracket tan theta into 1 minus tan theta plus sec square theta divided by 1 minus tan square theta. Now multiply tan theta with the bracket 1 minus tan theta, that is tan theta into 1 is equal to tan theta minus tan theta into tan theta is equal to tan square theta. We know that sec square theta is equal to 1 plus tan square theta. So we can replace sec square theta with 1 plus tan square theta, and the denominator remains as it is. Here negative tan square theta cancels with positive tan square theta. So the left hand side equal to twice sin theta into tan theta plus 1 divided by 1 minus tan square theta. Now apply the formula of x square minus y square is equal to x minus y into x plus y. Let us suppose x equal to 1 and y equal to tan theta. So x minus y equal to 1 minus tan theta and x plus y equal to 1 plus tan theta. Therefore, LHS is equal to twice sin theta into 1 plus tan theta divided by 1 minus tan theta into 1 plus tan theta. Here 1 plus tan theta cancels out, leaving us with left hand side equal to twice sin theta divided by 1 minus tan theta. Comparing the left hand side with the right hand side of the equation, we can say that both the right and the left sides are equal. Let us take the third example. Would you tell me which side is more complicated? It seems that both sides are complicated. So we will simplify both sides of the equation separately. Let us first take the left hand side of the equation. Now apply the Pythagorean identity involving cosec theta and cot theta. We know that cosec square theta minus cot square theta equal to 1. So we can replace 1 with cosec square theta minus cot square theta. Now apply the formula of x square minus y square is equal to x minus y into x plus y. Let us suppose x equal to cosec theta and y equal to cot theta. So x minus y equal to cosec theta minus cot theta and x plus y equal to cosec theta plus cot theta. Therefore, LHS equal to cosec theta minus cot theta into second bracket cosec theta plus cot theta divided by cosec theta minus cot theta minus 1 upon sin theta. Here, cosec theta minus cot theta cancels out, leaving us with cosec theta plus cot theta minus 1 upon sin theta. But we know that 1 upon sin theta equal to cosec theta. So LHS is equal to cosec theta plus cot theta minus cosec theta. Here positive cosec theta and negative cosec theta cancels out. So LHS is equal to cot theta. Now let us take the right hand side of the equation. Again use the identity involving cosec theta and cot theta. We know that cosec square theta minus cot square theta equal to 1. So we can replace 1 with cosec square theta minus cot square theta. Now apply the formula of x square minus y square equal to x minus y into x plus y. Let us suppose x equal to cosec theta and y equal to cot theta. So x minus y equal to cosec theta minus cot theta and x plus y equal to cosec theta plus cot theta. Therefore, RHS is equal to 1 upon sin theta minus into bracket cosec theta minus cot theta into second bracket cosec theta plus cot theta divided by cosec theta plus cot theta. Here, cosec theta plus cot theta cancels out, leaving us with RHS equal to 1 upon sin theta minus into bracket cosec theta minus cot theta. But we know that 1 upon sin theta equal to cosec theta. Therefore, RHS is equal to cosec theta minus cosec theta and minus minus plus cot theta. Here, positive cosec theta cancels with negative cosec theta. Therefore, RHS is equal to cot theta. Friends, it is time to compare the results which we have obtained. Comparing the left hand side with the right hand side of the equation, we can say that both the right and left sides are equal. Friends, look at the fourth example. I will explain it two times. First, I will explain it step by step with the help of algebraic formulas and trig identities. Then I will teach you how to write in the examination to save time. We can observe that the left hand side is more complicated. Let us take the left hand side of the equation. For simplicity, we will subtract the fractions denoted by the red colors. Here, the first fraction remains as it is. Look at the blue arrow. We have sin theta into sin theta is equal to sin theta whole square. Now see the pink arrow. We have 1 minus cos theta into 1 plus cos theta. In the denominator, see the golden arrow. We have 1 minus cos theta into sin theta. Again, the first fraction remains as it is. We can write sin square theta in the place of sin theta whole square. In the second fraction, apply the formula of x minus y into x plus y is equal to x square minus y square. Let us suppose x equal to 1 and y equal to cos theta. So 1 minus cos theta into 1 plus cos theta is equal to 1 square minus cos square theta. That is 1 minus cos theta into 1 plus cos theta equal to 1 minus cos square theta. Again, the denominator remains as it is. Therefore, LHS equal to sin square theta upon 1 plus cos theta. And in the second fraction, recall the Pythagorean identity 1 minus cos square theta is equal to sin square theta. Now we can observe that positive sin square theta cancels with negative sin square theta. Therefore, LHS is equal to sin square theta upon 1 plus cos theta plus 0 upon 1 minus cos theta into sin theta, which is equal to 0. That is, LHS is equal to sin square theta upon 1 plus cos theta. Again, recall the identity sin square theta equal to 1 minus cos square theta. Therefore, LHS is equal to 1 minus cos square theta upon 1 plus cos theta. Now apply the formula of x square minus y square is equal to x minus y into x plus y. Let us suppose x equal to 1 and y equal to cos theta. Then x minus y equal to 1 minus cos theta and x plus y equal to 1 plus cos theta. So LHS is equal to 1 minus cos theta into second bracket 1 plus cos theta divided by 1 plus cos theta. Here 1 plus cos theta cancels out, leaving us with left hand side is equal to 1 minus cos theta. Here we can observe that the left hand side is equal to the right hand side is equal to 1 minus cos theta. Friends, look at the time saving method. Let us take the left hand side of the equation. We know that sin square theta is equal to 1 minus cos square theta. So we can replace sin square theta with 1 minus cos square theta. Here the denominator is 1 plus cos theta. Now let us simplify the fractions denoted by red color. Here sin theta into sin theta equal to sin theta whole square. Look at the pink arrow. we have 1 minus cos theta into 1 plus cos theta, and the denominator is 1 minus cos theta into sin theta. But we know that x square minus y square is equal to x minus y into x plus y. Let us suppose x equal to 1 and y equal to cos theta. So x minus y equal to 1 minus cos theta and x plus y equal to 1 plus cos theta. So we can replace 1 minus cos square theta with 1 minus cos theta into 1 plus cos theta. In the second fraction, we have sin theta whole square is equal to sin square theta. For the factors 1 minus cos theta into 1 plus cos theta, we can use the formula of x square minus y square in the reverse order. That is 1 minus cos theta into 1 plus cos theta is equal to 1 minus cos square theta. The denominator remains as it is. The factor 1 plus cos theta cancels out from the first fraction. So the LHS is equal to 1 minus cos theta plus sin square theta minus 1 minus cos square theta. But we know that 1 minus cos square theta equal to sin square theta. So we can replace 1 minus cos square theta with sin square theta. Here positive sin square theta cancels with negative sin square theta. Therefore, LHS is equal to 1 minus cos theta plus sin square theta minus sin square theta equal to 0. So the second fraction equal to 0 upon 1 minus cos theta into sin theta, which is equal to 0. Therefore, LHS equal to 1 minus cos theta. Hence, we have LHS equal to RHS equal to 1 minus cos theta.